It's a beautiful day for flying, and we're going to go out and take a slightly wild airplane ride and learn a little bit about forces and acceleration and what happens to that most familiar of all forces, gravity, when we're in an accelerated reference frame. That's something that's pretty easy to do when we're in an airplane like this one. Let's go. In a few minutes, we'll begin a flight that will show us what happens when gravity goes away. Now, we can't really make gravity go away. It's present, of course, on the surface of the Earth, but also even in orbit. The space station, as it's in a circular orbit around the Earth, is constantly accelerated towards the Earth's center. And so it's falling, but at the same time moving sideways at just such a rate that it never gets any closer to the center of the Earth. And the astronauts inside experience a prolonged period of weightlessness. Now, we can't put this airplane into orbit, thank goodness, but what we can do is, from level flight, put the airplane into a dive. We'll pull out, and at the bottom of the dive we'll experience some excess acceleration, about 2 times the force of gravity. We'll start a climb again, and then we'll go over the top of a parabolic arc. And while we're flying through this parabolic arc, we'll experience a few seconds of weightlessness. We have some props on the airplane, including this helium balloon and another balloon which just has air in it. And these will allow us to see what happens when gravity goes away. Okay, we're all strapped in, ready to start the engine and get going.
The Skywagon 23 Charlie is holding short of 21 at Bravo, ready for takeoff 11 right, or we could take 21.
Skywagon 3 Charlie, roger. Runway 21 at Bravo, clear for takeoff and turn left on course.
We're up at altitude now and ready to begin our first experiment. From level flight, we'll dive, then pull up and feel not only the force of gravity, but an additional heaviness as we're accelerated upward to begin flying through a parabolic trajectory. And while we're going through the parabolic arc, we'll experience not just zero gravity, but a little bit of negative gravity. Let's see what happens to these balloons. Into the dive. Not much happening so far. Pick up some airspeed. Pull out of the dive. Not much happening here. All right, now what happens? Oh, look at that helium balloon. It's dropping. And comes back up again. Okay, let's take another look at that through a different camera. Okay, here's another look. Over the top. Well, that was so much fun, we'll have to try it again. Here we go, into our dive. Picking up airspeed. Pull out of the dive. We feel heavy. Helium balloon doesn't care. And now, negative G's. Helium balloon wants to go down. Blue balloon wants to come up. And I come up out of my seat. We climbed back up to our target altitude of 3,000 feet above the ground and have done a little quick change here to look at a different set of experiments. We've hung a little fishing sinker pendulum above a scale with a weight on it. This scale, whose needle is normally at the 3 o'clock position, will show us the amount of vertical force we're experiencing under different conditions. And we see the pendulum swinging back and forth, and its frequency, or the rate at which it's swinging, is about 1.5 back and forth swings per second. Now it happens that the frequency of a pendulum increases as you increase the force acting on it. And it slows down when you decrease the force. Let's watch what happens to the pendulum's vibrations as we bank the airplane 60 degrees to the right and turn in a circle. While we maintain level flight, the vertical force we feel becomes twice as great. We feel heavy, and the pendulum's frequency seems to have increased noticeably. Here's the pendulum in level flight. And here it is again while we're turning sharply. Let's see what happens to the frequency of the pendulum as we put the airplane into a dive. Pull out, feel about 2 Gs, and then go through a zero gravity maneuver. Okay, we're feeling heavy now. Pendulum frequency increases. Now we're light. And look what happens to the pendulum. The frequency slows way down. Let's make the fishing sinker spin in a circle. Give it some angular momentum. After it starts rotating, it wants to keep this angular momentum, which depends both on the speed of the weight and the size of the circle it's making. Now, when the weight is forced down as we pull out of the dive, the circle gets smaller, so the speed has to increase to keep the angular momentum the same. What do you suppose will happen when the vertical force is reduced during zero gravity? Dive. Pull out. Pendulum frequency increases. Then zero gravity. I have a couple of assistants with me, Noah and David, who are going to show some neat tricks you can do with zero gravity. They've been waiting in the wings, so to speak, or on the wings maybe. We'll start with Noah. Okay, here's the lighter than normal juggling. More or less normal juggling. Now what happens when we make gravity go away? Whoa! All right. Hey, I think that was good.
That was fun.
All right. Pretty much normal, a little bit heavier, and now, oh, lightweight juggling. Okay, Noah, now what we want to see is some juggling with just 2 balls in zero gravity. All right. That's
Actually
great.
stuck in up into my hands.
Oh.
Actually, that was pretty cool.
Okay. Shall we do it again?
Sure.
Okay, that was great, Noah. Now we'll ask you to step outside the plane briefly, and we'll bring in David. And David will show us some things you can do with a Slinky. Take it away, David.
Hello everyone, my name is David, and I'm from the University of Arizona, a physics student.
and I'll be giving a quick demonstration today on what you can do with the Slinky in 0G. As you can see, this is the classic metal Slinky. Right now I'm just moving it back and forth, and we're going to be doing stuff with it at 2Gs and in 0 gravity.
We'll start with a little bit of extra G's here. We'll pull about 2 and see what happens.
As you notice, wow, the Slinky actually becomes faster now. And it floats.
Okay, was that fun or what?
That was actually pretty cool.
I think that was great.
Now we'll be doing a demonstration of Hooke's Law, which is basically a Slinky or a spring will stretch out if it has a certain mass at the end. And well, this Slinky has its own weight. And as you see it has a certain length. And as we go to 2Gs, it should get twice as long. And as we go to 0G, it should shrink down. You see, this is the fun we get in 0G. Woo! Look at that! It's like hit me in the head too.
Well, David, you know, I'm getting a little bit thirsty. I would be interested in something you might be able to cook up for us back there. What do you got?
Well, I got a root beer here.
Okay, well, can you make a root beer float? Okay, root beer float coming up.
There we go. And sorry about that, but my feet also floated up too there. So. There we go. I'm sure everyone saw that.
Great.
And there we had a root beer float.
Okay, terrific. Well, thanks very much, David.
Well, thank you, Dr. Carson. Thank you for this wonderful trip in 0 gravity.
Well, we're headed back to the airport now. I hope you've had as much fun as I in watching the effects of forces in an accelerated reference frame and seeing what happens when gravity goes away.